Okay, welcome back. We're going to try making this enumerative cipher algorithm again, except not in native Python, but in C++. I had enough of Python. The reason we're going to do it is simply because I'm tired of Python and I want to do something else for a change. I mean, there are all kinds of other languages we could use. We could implement it in F sharp. We could implement it, in Python. But I just feel like doing it in C++. It's going to be more fun. And besides, I need to test out the new Cuda backend. Python Cuda, C++ Cuda. Okay, good. Now, okay, let's see what happens when I try to build this in the new backend. Build file. Return type of domain. Should be an I32. Okay, I32. Let's start it again. Now let's see what happens. Now we have these two. Also, this is how it gets compiled. I mean, everything that we've actually written for the CUDA backend should work as is. But the C++ stuff, let's see. CUDA occupancy, max potential cluster size. Let's see, where's this? So this is where it's set. This is for the kernel. What's this V0? That's the CUDA launch configuration. Okay. Okay, so that's one thing. The main thing that I'm wondering is how exactly are we going to compile this? I mean, CUDA, C++. Oh, oops. I mean, can I actually somehow run this? Okay, run C++. Oh, so it does have programs be specified in the request arguments. Okay, what exactly does this mean? CUDA C++ launch. We can just put in a file. Oh, nice. I didn't realize this. I mean, this thing CUDA C++ launch. This is a configuration for when I did what? When I tested some Cutlass examples while I was working at Tau City. Bring launch task, build Cuda program. Yeah, I suppose that makes sense. Okay, let's see what the tasks are. Configure tasks. Build Cuda program. Let's see, where's the Build Cuda program? Oh, really? Can yeah, I made this build script, and that's specifically for running Cutlass programs, and it kind of looks like this. So it has a path build only. I pretty much forgot about it by now. It's also including Thunder Kittens. Okay, maybe we can disable that. PS script root. Okay, let's path output. Blah, 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 blah. Okay. The only thing that I'm wondering is, can we just put a file like this? Program. I'm actually surprised myself exactly how much work I did. Build only. Actually, this should be build and run Cuda program. And Depends on. Okay, okay. So how about we do it like this? Run Cuda program. And instead of just building it, we have to do depends on. Kind build is the phone true. Yeah, so this is default. Okay, run Cuda program. What's the type? I mean, oh yeah, I think maybe okay, here I need this. I mean, once it's built, we just have to run the file. And in fact, yeah, we shouldn't be running it in PowerShell. But how exactly do we run it directly? Like command npm. Wait, process. Okay, how about we do it like this? We don't need the arguments. Current working directory. Wait. It should actually no. It's fine. No, but wait. We have the file. And it's going to put it in the bin directory, and I'm not sure exactly that's what I want. Like this kind of makes sense if we are running the entire thing in the current working directory. Okay, this is an interesting challenge. How exactly do we compile it? How exactly do we compile this properly? For now, okay, I'm going to put in the depends on. CC group build. Maybe we can just put it as build. Oh wait, this doesn't actually compile it. And we just need to put the label. Okay, this is okay. We could do test out this path. So launch, pre-launch task. And we cannot really launch it on the file itself. So it has to basically be on the bin thing. But yeah, this actually won't work. Instead, we need to do, yeah, this is going to be something like test 20 q and file base name, no extension, nothing file. Yeah, okay, let's just test out the build task. Let's see, how do we do that? If we go in here and then run task, Build Cuda program, let's see whether that works. Turn std C++20. Okay, so what exactly is wrong with this? I mean, maybe simply because I commented out the Thunder Kittens thing. But since we're just testing this thing, let's change the default task to Build Cuda Program. So we're going to move the group here. We're going to remove this. Now when I get here, I can just press Ctrl Shift B to this will run the default task. Oh yeah, this worked, and now we have this bin directory, and this is the executable file. I mean, the only question is how exactly do we get the resulting file name? And the problem is that we're not really using something like a PowerShell script or a Bash script, so we cannot really just trim the Q extension and then somehow insert this bin here. I mean, the easiest thing I could do is maybe to just append an executable, something like file exe. And what exactly would be? I mean, there are a bunch of these things: VS Code, file dir name. Maybe we could do file dir name bin. Okay, so maybe. Okay, I'm getting an idea. Okay, file dir name. The current open files dir name, and then bin, and file base name with no extension. Yeah, this could actually be it. Run Cuda program, and then in launch, let's see. Okay, actually, we don't need this run Cuda program. Instead, we just have to run it in with the debugger. So let's do this. Oops. Recon launch, pre-launch task, Build Cuda program. So yeah, I think this could be okay. Okay, if I now do a run, let's see, not this, but start without debugging, or actually we can just select it here, not the Python debugger, but the Cuda C++ thing, and then, okay, let's press it. VS Code bin launch. Oh yeah, we're actually running it on this file instead of this. Sorry about that. I mean, it seems like it actually finished. But what happens if I press Shift F5? Nothing is happening. Let me just go into this directory and then I'll try running this executable like test 20. Oh, nothing is happening. Yeah, so that's why nothing was getting printed in the debugger. And why exactly is that? I mean, it should be launching the kernel, but I don't think it has a device synchronize anywhere. Oh yes, oh yes. Oh, how do I do the device synchronize? Let me go into Core CUDA. I think maybe, in fact, I don't even need to go there, but I can just try device sync. And yeah, that's how it is. It's called in the library. Should be used on the host side. So let me try building this again. And yeah, now it's doing a device synchronize. Now if I press Shift F5, for fuck's sake, why is nothing happening? Shift F5. Okay, this is just F5. Okay, it's printing it here. But why is Shift F5 not working? Let me just do keyboard shortcuts. And if I press F5 here, sorry, I need to test why the hotkey is not doing anything. If I press F5 here, that's F5. And if I press Shift, I don't know. Maybe there's some kind of a conflict going on with the shortcut. Shift 5. CMake debug. Debug disconnect. Debug stop. Debug restart. It's Control F5. Oh, what the fuck. And one of the problems is that it's showing me the build instead of sound run. Okay, instead of doing it like this, I don't want it to run every time in the debugger when I am, when I'm trying to just run it normally. So we're going to, in fact, just make that task again. Like, fuck, oh great, it's still here. Nice, nice. So, run build task. And let's set this to false. And now this is going to be the default build step. So let's say I press Ctrl Shift F5, it will build it, and then yeah, it will run it. Just have to press Ctrl Shift and B. Okay, this is great. This is very convenient. Nice. Let's do a tiny change to the build script. We're going to remove this. And let's see, where's the build? We're going to replace this with a switch. Yeah, nice. So this part just tests the status code of the last executed command, which is the call to nvcc. And then this tests whether the switch also is positive. And this part actually runs the binary. Also, in Run Cuda program, we could make the current working directory the binary directory. Like, we don't need it to be in the workspace folder. Run Cuda program, and let's also do the same thing in launch. I mean, it's weird. Doesn't it have something like a current working directory? CVD. Oh yes, okay, I like this. Yeah, before we commit, let's just try running it again. Let's press Ctrl Shift B. It works. Let's press Ctrl F5. It works. It's really good that we have this build script. I think I translated it based on I created it based on what the build command was in the previous version of the library. These are all the settings that we are passing in. Maybe instead of architecture native, maybe we could put in SM120A. SM120A. I think that it was done like that in Cutlass studies. Let me just recent folders. This is how we build the Cutlass examples. And yeah, I have architecture SM120A, and I was missing an underscore. Okay, so let's try building this again. Ctrl Shift V. Oops. Excellent. I pressed Ctrl V. Oh, too big. Max reg count. Value specified 255. Will be ignored. Okay. Really? Why is it too big? Like if I put in 128, what will happen? Whoops. I didn't mean to run the build on this. I mean, exactly how many grid dimension is 84, block dimension is 256. Okay, yeah, I don't think this block dimension is way too large for the amount of registers that we're trying to use. Let me just see in core CUDA how it is supposed to be determined. I have a function here that calculates the And the register count, I think maybe it's, yeah, I think, yeah, it's like this. Transfer block 256 should be 255. Oh yeah, so it is right. Let's try 32. I'm just curious what would happen. Okay, I don't understand why we're getting this kind of error. And we weren't getting it before. It's got a lower bound of 24. What if I try putting in 120? I mean, not 120, but instead of 120A, if we just put in just SM 120 like this. The difference between the two versions is that this A, that would have the non-forward compatible features. So yeah, if I put in native, I think it just compiles it for SM120. But if I put in 120A, I think it also allows the GPU-specific features that aren't necessarily forward compatible. So maybe we could just maybe get rid of this. Yeah, okay, let's forget about the max register count. The CUDA no have conversions. I mean, this thing is simply here because Catalyst was giving me some kind of giving me errors. At least that's why I think it was. I cannot forget by this point what exactly was it. These are device optimizations. These are restricted pointers. These allow constant expressions to be run regardless of whether they're on device or host. This generates the line info on the host. This generates the line info on the GPU. This I think this turns off the asserts. It defines this symbol which get passed into the assert header, and it disables the asserts. So they're So they're doing nothing at runtime. Yeah, I kind of like this build script. It's kind of, yeah, it's pretty convenient. And I'm really happy how it went today. We can very easily compile C++ programs with, just going into the file, pressing Control Shift B. It would actually take a significant amount of time to build this if I didn't have it already. And I only built this script so I can actually test the Cutlass examples. So it went very nicely. Okay, maybe let's just put in some comments. Build the script for the pool files. It's used by the VS Code tasks. And not exactly, not just tasks, but this is launch configurations. No. I mean, no, the launch configuration isn't using this directly. It's just passing, only the task is using this to build the binary. And yeah, not bad. We managed to figure out how file VS Code, the files in VS Code. And I'm actually going to make this a separate video since it might be useful to other people besides myself. It's very self-contained, and other people looking for ways of using the NVCC compiler in Visual Code will find it useful. I'm going to take some time to post it on my YouTube, and then we're going to move on to the next step.